In the next few examples, we'll look at setting up some linear inequalities and use Symbolab to solve those. In example 11, Francis wants to buy coffee for their coworkers. If everyone's favorite drink costs $4.18 with tax, we want to find the maximum number of drinks they can buy if they have $20 to spend. So we're told that the drinks cost $4.18 with tax. From that, we can set up the expression 4.18 times x, where x represents the number of drinks. Then we have a limitation here. If the maximum number of drinks, how many drinks can they buy if they have $20 to spend? And that's the maximum. We're trying to find the maximum number they can purchase. So we could add to this that has to be less than or equal to $20 to make sure we're not exceeding $20 with how many drinks we're purchasing. Then in Symbolab, we can solve 4.18x, use the less than symbol, and then the equal symbol to get less than or equal to 20. And we're given our results in a few different formats here. We'll use that decimal value of 4.7847 once we round it, which tells us that x has to be less than or equal to 4.7847. Now we need to translate that into something practical. That tells us that they can buy at most 4 drinks. If we rounded that up to 5, that would be too large. That would push us over our budget. So if we can buy 4 and a little bit more than 4.5 drinks, we have to round that down to the nearest practical value, which would be 4. In example 12, Sarah charges their client $17.50 per project, meaning Sarah earns 17.5 times x, where x is every project completed. We want to find how many projects they must complete if their goal is to earn at least $1,200. So however much they earn, that 17.5x needs to be greater than or equal to that value of $1,200. We can flip back to Symbolab and ask it to solve this inequality. And we get x has to be greater than or equal to 68.5714. Since x has to be something greater than or equal to that, we have to round up to the nearest practical value, which means that she needs to complete, or they need to complete, at least 69 projects to hit that target goal. In example 13, Cleveland wants to throw a birthday party for their son. Indoor climbing gym charges a $950 rental fee plus $13.50 per child attending. So this is going to set up how much we're spending. $950 is a flat fee plus 13.5x, where x represents how many children are attending. And they want their maximum cost to be $1,200. That means this value, this expression we came up with, has to be less than or equal to $1,200. So we'll solve that expression, set to be less than or equal to $1,200, and we get x must be less than 18.5185. Translating that again into practical terms, that means that they can invite at most 18 kids. Because if they got up to 19, then they'd be exceeding that budget limit that they've got in place. In example 14, Connor charges clients $75.50 per project. So 75.5 times X. Now in this case, we have monthly business expenses that we're taking into account of $2,300. So from that amount that he brings in, we're going to have to subtract out $2,300 per month. We want to find how many projects they need to complete to earn a monthly profit of at least $2,100. Meaning this expression we just set up needs to be greater than or equal to 2,100. Again, using Symbolab to solve. Tells us that X must be greater than or equal to 58.2781. And in practical terms, what that means is he needs to complete at least 59 projects a month. Because at only 58 projects, he'd fall short of the profit he wants to bring in each month.